Good morning. In this video, we will discuss the switching. Switching is in the first unit, Introduction and Physical Layer. Last video, we discussed about what is switching and what is circuit switched networks. Already we discussed that is switched networks are divided into three categories: circuit switched networks, packet switched networks, and message switched networks. The packet switched networks are also divided into two categories. One is datagram networks and the second one is the virtual circuit networks. Packet switching, here data communication, we need to send messages from one system to another system. If the message is going to pass through a packet switched network, it needs to be divided into packets of fixed size or variable size. That is, the packets are divided into two categories. One is fixed size packets, and another one is the variable size packets. So here these packet sizes determined by the network and the governing protocol. There are two types of packet switched networks already I told, that is datagram networks and virtual circuit networks. First one is the datagram networks. In a datagram network, each packet is treated independently of all others. Packets in this approach are referred as the datagrams. Datagram switching is normally done at the network layer. Different packets from same message may travel through the different path to the destination. Packets may arrive at the destination out of order. Packets may also be lost or dropped because of lack of resources. Consider this. Here, A is the sender, X is the receiver. A wants to transmit the data into X. So the whole data is divided into datagrams. Here, 4 datagrams, 1, 2, 3, and 4. Here, we are having so many paths. That is, this one to this router to this router, this router to this router, and destination. Here, another path is this router to this router, this router to this router, and destination. And here, this path, and then suppose this one to this one, this one to this one, and this one to this one, the same thing. This one, this router to this router, this router to this router, and this router to this router. So we are having so many paths. Here, the connection is not established just according to the available resources, the datagrams are traveled. So here, the first datagram is traveled from this router to this router, and this router to this router, this router to this router, and from this to destination. Next, second is traveled from this router to this router, and this router to this router, and then from this to destination. 3, from this router to this router, and this router to this router. 4, this router to this router, and this router to this router, and receive and transmitted to receiver. But the receiver receiving all the 4 datagrams in this order 1, 4, 3, 2. Then how the datagrams are arranged? So for that, in the datagram header, we are having IP address along with the sequence number. Each datagram is having the sequence number. So that sequence number is used to reconstruct all the datagrams order. So the using the sequence number only, the datagrams are rearranged. So here A transmits the data to X. Here 5 routers are used to transmit the data. So here any one of the, that is all the paths are used to transmit the data. Here each router is having the routing table. So here the routing table contains the destination address and the output port. Each packet in a datagram network carries a header that contains among the information the destination addresses of the packet. When the switch receives that packet, the destination address is examined. The routing table is consulted to find the corresponding port through which the packet should be forwarded. For example, the first datagram is received from this one means, then it checks the IP address and what is the next router to transmit the data. So for that information is get from this routing table and it transmits the data to the next router. And the next router is also having the routing table. So it also checks the IP address and according to the IP address, it transmits the data into the next one. Efficiency compared to the previous one, this efficiency is high. So here we find out the total delay. Consider here, this is the transmission time between A and X. Here consider A and B are the source and destination, and in between A and B, two routers are there. So first, just it transmits the A transmits the data into the first router, and first router finds the path to the next router. So that is the waiting time, and finds the path and transmits the data into the next router. Here also the waiting time, because the next router finds the path to transmit the data into the destination. So next it is transmitted into the receiver. So here the waiting times are 2. So the total delay is 3 transmission time plus 3 propagation time plus waiting 1 and waiting 2. So in this way we calculate the delay. Here we differentiate the circuit switched network and packet switched network. In circuit switched network, the channels are reserved before data transfer. But in the packet switched network, channels are not reserved before the data transfer. Ideal reserved resources cannot be used by any other ongoing communication in the circuit switched network. But the ideal resources can be used by other communication networks in the packet switched networks. In circuit switched networks, there is no waiting time because before transmitting the data, the connection is established. So the data is transferred directly to the receiver through that in between the switches or router. But in the packet switched network, at the time of transmission only it finds out the path. So according to the availability of the router only, the informations are passed from one router to another. So here the waiting time is there, and circuit switched network is not efficient compared to the packet switched network. And circuit switched network is suitable for real-time services, but packet switched networks are not suitable for the real-time services. The circuit switched network is connection oriented because before transfer the data, the connection is established and then only the data is transferred. But in the packet switched network, there is no logical connection between the source and destination. So packet switched network is the connectionless network, and in circuit switched network allocates dedicated transmission rates, but it allocates the variable transmission rate based on the demand. And circuit switched network supports less user time simultaneously. Packet switched network supports more users simultaneously. Thank you.